Today we're going to look at writing the equations of parabolas. By the end of this video, you should be able to write the equation of a parabola in standard form. Just a reminder, we have two types of parabolas. We have a vertical parabola and a horizontal parabola. For a vertical parabola, the equation is x minus h squared equals 4p y minus k. And for a horizontal parabola, you have y minus k squared equals 4p x minus h. So to write the equation of a parabola, we first need to decide whether it is a vertical parabola or a horizontal parabola. Then we need to find the vertex, which is hk, and we need to find the value of p. Once we have those three things, we can write our equation. First problem says, write the equation of the parabola that has the vertex at the origin, its axis of symmetry is the x-axis, and it contains the point -1/2, 2. Then state the focus and the directrix. So, we are told that the vertex is the origin, which is 0, 0. We are also told that the axis of symmetry is the x-axis. So this tells us that we are going to have a horizontal parabola. Then we are told that this graph contains the point -1/2, 2. So that would be here. This means that our parabola is going to be facing the left when we sketch it. So let's plug in what we know. We know that we have a horizontal parabola and the vertex is 0, 0. So we have y squared equals 4p times x. Since we are given this point, we can plug these values in for x and y, which gives us 2 squared equals 4 times p times -1/2. When you do the algebra, you end up with p is -2. Now that we have the vertex, the value of p, and we know that it's a horizontal parabola, we can plug all that back in and get our equation, which would be y squared equals 4 times p, which is -8, x. Since it also specifically asks for the focus and the directrix, we need to find those. We know that the focus is p units from the vertex, so the focus will be at -2, 0. And then we know that our directrix will be p units in the other direction from the vertex. So our directrix is the line x equals 2. Next, we have write the equation of the parabola that has its focus at 0, 4, and its directrix is the line y equals -4. So, we know that the focus is 0, 4, and the directrix is y equals -4. So from this, we can tell that this will be a vertical parabola. We also know that the vertex is halfway between the focus and the directrix, So that puts our vertex at 0, 0. We know that P is the distance from the vertex to the focus, so that will be 4. Now, you need to be careful here and check your signs for P. The parabola will always open so that the focus is on the inside of the parabola. So we can double check. That means that our parabola will open up, so P should be positive. Now we have all the information we need to write the equation. So we know it's a vertical parabola. So we have x squared equals 4 times P times y. Next, we have write the equation of the parabola that has its vertex at -2, 3 and its focus at 0, 3. So our vertex is -2, 3, and our focus is 0, 3. As I mentioned with the last problem, we know that the parabola will always open toward the focus, so we know that this is going to end up being a horizontal parabola that opens to the right. We are told that the vertex is -2, 3, so we just need to find P, which is the distance from the vertex to the focus, which in this case is 2. Since we just said that the parabola will open to the right, that means that P is positive. So now we can write our equation. Since this is a horizontal parabola, we are going to have y minus 3 squared equals 4 times P, which is 8, times x plus 2. Lastly, we have a word problem. We are told that a satellite dish is shaped like a paraboloid of revolution. This means that you take a parabola and you rotate it so that you get a 3D object, which would be like a satellite dish. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point. Lastly, we have a word problem. A satellite dish is shaped like a paraboloid of revolution. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point where the receiver is located. If the dish is 8 feet across at its opening and 3 feet deep at its center, at what position should the receiver be placed? So first of all, a paraboloid of revolution is when you take a parabola and spin it on its vertex to create a 3D object. So this means we've just taken a parabola and rotated it to create our satellite dish. We want the receiver to be placed at the focus of this satellite dish. So really, this problem is asking us to find the focus. So, to make our lives easier, I'm going to put the vertex of our satellite dish at 0, 0. We know that the satellite dish is 8 feet across and 3 feet deep, meaning that the ends of the satellite dish should be at -4, 3 and +4, 3. So our satellite dish looks like this. We want to know where the focus is. So clearly, this is a vertical parabola. We created this so that the vertex is 0, 0. We need to figure out what P is. Well, let's start with writing out what we know. Since it's vertical and the vertex is at 0, 0, we have x squared equals 4p times y. Now, we also know 2 points on this parabola. I'm going to go ahead and use 4, 3. So I'm going to plug that in for x and y. And then we just need to solve for p. So we have 16 equals 12p. So p is 4/3. We are not asked to find the equation of the parabola, but we do have enough information to do so at this point. What we really want to know is where the focus is. And we know that the focus is p units from the vertex. So that means that our focus should be 4/3 from the vertex. So that puts our focus at the point 0, 4/3. Now, with word problems, we want to make sure that we answer the problem with a sentence. So the receiver should be placed 4/3 of a foot above the center or the vertex of the satellite dish.